Hello everyone.
Hi.
Welcome. So today we will try not to get lightning struck, and we will talk about value types, and we'll see how they can help enhance performances. And it's not limited to that. We'll see after. So today on the agenda, so I'm trying to switch. Yeah, we are going to write small Java application, weather app. So we are going to fetch weather information from an API, and we will be doing some simple calculation on the data, and there will be lots of data. So for that, we will be manipulating some simple domain objects to represent weather information, temperature, wind speed, precipitation for rain and snow, and we will have some aggregated results. We will be computing minimum, maximum, sum. So really basic stuff, but on a huge amount of data. So we will be using this free API called OpenMeteor. So that's not an ad, but we will be using this API, which is quite useful. It's free. And more specifically, because we are not going to get forecasts, but we are going to query some historical information. And for that, we will be providing a specific location on the Earth, the sampling of data, so we will be getting hourly values, and for a pretty huge amount of time, 20 years. So if you do the math, we will be having 170K data for each information, like temperature, wind speed, precipitation. So here is the API. It looks like this. We have a base URL, of course. We have the position, latitude, longitude, the time frame, the start and end dates, and the kind of information we are interested in, temperature, wind speed, precipitation, as mentioned. And the result will look something like this. And the interesting part for us is what we have at the bottom. We have some arrays of data. We have, again, temperature, wind speed, precipitation. And we will have, for each of them, 170K around values. OK. And we will be calculating some information. So that's our goal today. But first, let's make a little detour about some new feature that came out in JDK 25. It's a new JEP called Flexible Constructor Bodies. It's in standard in JDK 25, so you can use it. It was in preview for a number of versions under different names, but now it's standard. And it allows us to do some stuff before calling this or super. Before this JEP, there was a golden rule. The first thing you had to do in a constructor was a call to super somewhere at the first. But now you can do stuff. What kind of stuff we can do? It's limited, but we can do integrity checks, and we can initialize fields. So now constructor can look like this. We have a first part called prologue, where we can do these integrity checks and field initialization. We have the call to super, and after that, we have the epilogue, where this becomes available, so we can call methods or do whatever we want. So let's play with that. So I have a simple class to represent my, maybe it's not.
Perhaps you should
switch to presenter mode. Oh, yeah. Yeah, that's better, I guess. So yeah, so what we had to do in the past was we had to call the super at first. Now we can do something a bit better. We can call it a bit later. And that's kind of interesting because now you can do integrity checks and you don't have to call super if the test doesn't pass. So you can avoid doing costly stuff when it's absolutely useless. And we can run it. And as you can see, I'm using the new GDK25 syntax, which is much simpler for the main, just void main. Yeah, it's... OK, so it works. It compiles. You can trust me now. And we can also put it at the very end of the constructor after the field initialization. Should be a bit quicker this time. Kind of. Yeah, OK.
So this is important. This means that you can control when this is fully initialized. So now we have a clear way to see if the object is fully initialized or not, which is great when you want to debug things, because before, when you wanted to debug things and you print the object, you didn't know if when the value was something like 0, it was because a bug inside the constructor or because just the field was not yet initialized. Now you have a clear way to know. After the super, we know that all the fields should be initialized.
OK, so that was it for the little detour. So let's switch for what you all came for, I hope. Value classes. So you just add this small keyword called value before the class declaration.
So
and voila, you have a value class. Yeah.
You can upload. I have this T-shirt to remember to thank IntelliJ, because as you can see, there is no red squiggle in the code. Actually, you can test value classes with the latest version of IntelliJ if you move the version. You have a special version called experimental in IntelliJ, and if you switch to experimental, you can already use value classes, which is great.
And as you can see on this value class, I put the super at the very end. We're going to execute it, the main. And you can see that it's a value class because we have this new isValue method added on the class. And it says true, so that's a value class. But the slight difference is that for value classes, we cannot.
Yeah. The IntelliJ version currently allow you to have the super at the beginning, but not Java-C. So for value classes, all the fields have to be initialized before the call to super. Value classes are fully immutable, so you have no way to access the object if the fields are not fully initialized. So, and if you don't write the super constructor, if you comment the first line, then the compiler will add it at the end, because this is a value classes. And for value classes, super constructor is always at the end.
It works. The compiler is nice for us. Same for records. Just add the value keyword before, and you have a value keyword. Super is added at the end by the compiler, and IntelliJ is wrong, but it's experimental, and it works. OK.
So value is something that you can use on classes and that you can use on record. It's just a supplementary bit that you use at runtime.
So let's do a little benchmark, maybe.
Where is Okay. So here I have a record with the wind speed. You can see that when I define min and max, recreating new object, and then just for the demo, I have 10,000 wind speed that I'm creating like this, and then from here I'm just computing the maximum and the minimum, reusing those methods. So this is basically the code that you should write if you don't care about performance. And now you have the magic trick, which is let's remove it, let's add value in front of it. And now we are telling the VM, and not the compiler. We are telling the VM that the VM should optimize this object and not do allocation when you have a new, but directly use all the value of all the fields. So we can run it, but it's not that useful because it's not a benchmark. So we have written a GMH benchmark for it, and this is the result. So the first line is for a classical class. Now the classical class are called identity classes, and so without the value modifier in front. And if you use just the keyword value in front of the class, magically you get basically exactly the same performance you get with a primitive, using primitives instead of using classes. That's all. Yeah, we have finished.
Questions?
Question? The thing we want to show is that it's not only a performance optimization. Yes, it's a performance optimization, but it's more than that. Usually in the past, we have written a lot of Java code with the assumption that creating objects had a cost at runtime. But now we can create objects with no cost at runtime.
That's great.
So let's think, what is your favorite code? And think about it. And now think that using new has no cost. Do you want to change that code now? Make it more explicit?
Yeah, so my name is Clément de Tast. I'm a tech lead in a French company called Siam. I'm in a number of social networks. I write some articles with some of my colleagues on the blog of my company. It's written in French, but if you can read French, I've written some stuff about value types. I like to do Java, JavaFX. Maybe I'm one of the 5 persons on the earth doing JavaFX, but I like it. And we can talk about beer and Java if you want, between sessions.
So you are at the right place. You are in Belgium, at Devox. So I'm Remi Forax. I'm a professor at a university which is in the east of Paris. I'm one of the guys that write the spec of Java. So things like modules, lambda, and so on, and currently value types. And I maintain also several open source projects that nobody uses.
Okay, so let's talk about Project Valhalla. So it's one of the different projects that we have in the OpenJDK, along with Ember, Panama, Loom, Babylon, Lilliput, many of them. So Valhalla is one of them. And last year in this very place, Brian Gertz gave a talk.
So Brian Gertz is the spec leader of this project.
Yeah, and his talk was named Java's Epic Refactor, and as you can see, the project started more than 10 years ago. It's quite a big change for the JDK. We have 3 goals for this project. Enhance the language with value objects, we've introduced them, which aims at combining the abstraction of object-oriented programming with the performance of primitive types. So you don't have to choose. And we have these 2 families of objects. Well, primitives are not objects, but we have primitive and objects, and there is kind of a gap between them. And the project intends at reducing this gap.
So yes, in the future, we want people to be able to write a list of int, and it should work. We hope, at some point, in 10 years.
So the project is composed of multiple JEPs. Some of them are not created yet, but this one is created. We will be focusing on this one. JEP 4.1, you can have a look on the OpenJDK website. You can see that effort and durations are extra large. We don't know if it's Elon time scale, but that's quite big. And let's make some...
Yeah, so before explaining how it works, what you can get with using value classes, let's explain what is a stack and what is a heap. So it should be obvious, but let's do it anyway. So the stack is where you are executing methods. Remember that in Java, you have 2 kinds of methods. You have the method written in bytecode, and at some point, they are transformed into assembly code. When you call a method, basically you push a stack frame on the stack, so all your local variable will be there. All your local variable are a multiple of 32 bits value. I think you all know that there is no point to using a short on stack, basically an int. We do exactly the same. So it's on stack where you do the computation, and you have the heap where you do the allocation. This is used to store the object with all the fields. When you allocate an object on the heap, you have the header of an object, which means that even if you don't have fields, you have some space which is reserved for it. Basically, you want to store the class of an object in the header, so you can answer to get class, by example, and you have several other things inside the header. And when you store fields, you use a multiple of 8 bytes. Bits, sorry, yes, 8 bits. And the current model, at least before Valhalla, is that primitives are stored directly. The value of the primitive is stored. And for references, they are stored as a pointer to an object on the heap. So why it takes 10 years or more? It's basically the first thing we want to do when introducing value classes is to have classes because we want encapsulation, but we want at runtime to be like a primitive. The first motto of the project was code like a class, works like an int. That's basically the idea. So we want to add something in between classes and primitives. What is a classes? When you have a classes, by default, when you create an instance, you will have a location in memory. That's what we call the identity of an object. you can check the identity using equals equals, and if two instances have the same identity, it will return true. Because you have that identity, you have this location in the heap, then you can mutate the fields, because all the fields are in the same place, at the same location in the heap. So for classes, you have fields. You can implement interface, and we have encapsulation. Instances are nullable, and you have integrity. We will explain exactly what integrity means. So that's for classes. And in the other side of the ring, we have primitive that have no identity. 12 has no identity. There is not a space in the heap to store 12. Do you agree? Yes. If there is no identity, there is no mutation. Because for mutating something, you need a place, and you need to know the place, so you can see the mutation. Primitive are flattened on stack. By flatten, we means you are using directly the value on stack and on heap. This one is harder. I don't know if you know, but if you have a 32-bit CPUs and you are using long and double, if you do a read, you will do 2 read, because you can only read 32 bits. So if you have a 64 bits value, you need 2 read and 2 write, which means that if you have several threads, you can see the part of the value from one thread and part of the value from the other thread. Obviously, you should use things like synchronize and so on, so there is no issue, but technically, the Java spec doesn't guarantee integrity for 64 bits value. And on primitive, we have operators. And at some point, we may want to have that on classes. So what are value classes? We are picking things from both worlds. So a value classes is a classes. So you have fields, methods, you have encapsulation, but no identity, so no mutation. You have the guarantee that value classes are flattened on stack, which means no pointer on stack. Direct values are used. On heap, it's more complex. It's maybe flattened, it's maybe not. We will explain why. It's written just after. We have null, and null is an issue when you want to store something on the heap. You may have no integrity. You can choose if you want to have integrity or not. And in the future, you will have operator on value classes. Not on all value classes, not all operators, but you will have operators on value classes.
Okay, so now that we know a little bit more about value classes, let's see them in action. Okay. So here I have my wind speed record, which is a value record. As you can see, there is the value keyword. And in the main, I'm creating 2 instances. So we have each time a new, but it holds the same value, 10. So what about equal equal? As Remi said, equal equal, it compares references, but we don't have identity on value classes. So the semantics is new. And what will be done is comparing the fields of the value class.
So basically, if you do an equals on a value class, all the fields are compared one by one.
And as you can see, it returns true. So we have two different instances, but they are equal. There is also some changes about the system.identity hashcode. I don't know if you know what it does. It returns the value of hashcode method, even if it's
so basically, if you
it's
don't
not
override, if you don't override the hashcode method and you ask for a hashcode, a value is returned. With an identity classes, the value is stored inside the header of the object, but with value classes, there is no identity, so no header, so we have to do something when you ask for the identity hashcode.
So yeah, so basically we don't have identity, so the algorithm will use the fields of the value class.
So the VM will use the fields. It's not specified if the VM will use all the value of all the fields. You only know that some value of the fields will be used to compute the hashcode.
And as you can see, we have the same values for two different objects.
Yes.
What about synchronization? So for synchronization, we need an identity. We don't have identity on value classes, so the code doesn't compile.
Oh, IntelliJ says the code doesn't.
Yeah, so we're gonna run it because we don't trust IntelliJ. You have the shirt, but you don't trust them a lot. Okay, so the compiler tells us we need a type with identity, so it does not compile. So maybe you can try to trick the compiler and do that. We will synchronize on an object. But this time, IntelliJ is not happy, but it compiles. We're going to see it. So it compiles, but we have this runtime exception called identity exception. So the VM will check at runtime that what we are trying to synchronize on is an identity object.
Yeah. And if it's a value object, you get an exception. So basically, again, for implementing synchronize, you need the header of the object because you change bits of the header of an object. And if you have no header, you have no synchronization.
So value types are great, but no synchronization on them. Okay. A word about equal equal?
Equal equal. So now it means that when you do equal equals on an object, if it's an identity object, you are comparing pointers, but if it's a value object, then you are comparing fields, which means that equals equals is now slow. Yes? You cannot use it in front of a dot equals saying I will improve the performance of my code by checking first using equals equals and then calling dot equals. Because if it's a value object, equals equals will check the fields and dot equals will recheck the same fields. So the code needs to be changed a little bit. You can see it in Java-util objects. So this is the current code of Java-util objects in the OpenJDK workspace, the Valhalla workspace. So you can see that if the preview feature is enabled, you don't run the same code as as before, because it's now stupid to do an equals equals in front of a dot equals. And you can see the performance. You can see the issue. So stop using equals equals, please, for your own good.
So okay, let's dive a bit more into the app. First thing, we need to query the API. We have some different parameters. So we are going to design a good old builder to create the query that will end into a URI object. So I'm going to, well, I've already written it. I've written it a beautiful builder to do that using identity objects, So that's my query builder. We have the position, lat long. We have the start and end dates. We do many integrity checks because we want the query to be valid. And we have this common pattern. You can see in the date range method. We are returning this. So we have this fluent builder API. We can chain calls. But we have to do the integrity checks again. Maybe I could have created a private method for it. So that was my take on creating a builder for it. But I guess, Remi, you can do
Yeah. It's a nice mutable pattern, but now that we have value types, we can create a true builder. Or that's basically the idea. Now that the cost of creating an object is basically 0, I can write a better builder, which is, I think it's yes. So
there.
Here, instead of modifying the fields, I use a record here, but basically I will write all my check in the constructor, and then if I want to change something, I will just recreate a new builder. And I will get exactly the same performance because I have used the magic keyword value in front of it. So I don't have to have a mutable builder anymore, because if you think, we write mutable builder now because we are afraid of the cost of creating a new object. But now that we have value classes, we are not afraid anymore. We can use the value classes to create a builder. And the beautiful part of it is that now all my checks are only in the constructor, and they will be run every time I recreate a new builder. So my code is both simpler, and I'm sure I will do all the check all the time when I populate with new values. So basically, this is a better builder. Yes? No? Maybe?
Maybe. Okay, so let's have a look at the app itself now that we have this beautiful builder using value record. So we want to collect data that was returned by the API. We want to compute some stuff, min-max, total precipitation, basic stuff. Okay, let's have a look at the code. If I want some strong typing, as we did in the app, so we're going to use objects, temperature, wind speed. Every time we do some operations, we return a new instance. So that's our model. We are doing some computations here. As you can see, we are using the methods min, max, etc. that return a new instance each time. So we aggregate all the results. So that's the slow code using identity objects. But if we want performances, we have to use, or we had to use primitives. So we have the same kind of model for primitives. I can show you the computations at pretty much the same methods, but using primitives. And we can maybe easily do some errors like mistaking temperature and a wind, because they are all floats or doubles. So I can make this kind of errors, but I will have performance because I'm using primitives. And we have the exact same code, except that we added the value keyword before our domain types. So the same temperature, the same wind speed with the value keyword. And we are doing the exact same calculations as identity objects. It's where it was exactly. Yeah. So we are using min-max, etc. methods. I guess we have some benchmark. Well, yes, first, benefits. As mentioned, using strong typing avoids making mistakes, like a wind speed is not a temperature. You can maybe pass the wrong type, wrong value to a method, but with strong typing you cannot. On primitives, you have no encapsulation. We have with objects, and it helps an overall better maintainability. The objects really tell what they are by essence, and they have encapsulation. We can have some behavior inside.
Yeah, here you have something which is you have a toString that will put the unit after the value. If you are using primitives, you have to take care of these kind of things. So this is a benchmark. This is the computation run using identity class or primitives. As you can see, you can understand why we are shy to create object just to represent one primitive values, because it has a real cost at runtime. But using the magic keyword value, we get exactly the same performance as with primitives, but writing the code we should write that encapsulate the value. Exactly. That's one of the promise of the value classes. Basically, for computation, you can have objects that at runtime behave like primitives. So this techniques basically is not done by the compiler. The compiler does nothing. The compiler just set a bit in the bytecode saying this is the value classes. So from the compiler point of view, value classes is exactly like a normal classes. There is no difference. The difference is only done as optimization is only done by the VM, which is a really, really great things. So this optimization is called scalarization. Scalarization is you take an object on the stack and you explode it and store all the value in registers, all the value of the fields directly in registers. Because this is done by the VM, it means that you don't have to recompile your code. As an example, Java util optional is now a value classes. If you are using the JDK of Valhalla, you have optional that is fully scalarized at runtime without needing to recompile at all.
So I can use old code with my new app and
Yes.
benefit from the
Yes.
optimization done by the JVM
You can take a library that was written
10 years ago, before Valhalla.
20-something years ago, and the VM will optimize it with your value classes automatically. That's why it takes a little time to get it right.
Okay.
So in the JDK, I don't know if you know, but currently you have an annotation for some classes that in the future, soon, will become value classes. The current annotation is value-based classes. And so things like the wrapper type, like integer, long, float, Java long double, are now value classes. which means that if you do a equals equals on them, it almost work. Almost. You still have double and none that still don't work, but
And the trick with the integer cache, not working.
it doesn't work anymore.
Yeah.
There is no integer cache anymore. You don't need it because now you have value classes. There is no allocation at all. This is true for optional and all his friend. This is true for the classes of Java time, like local date and so on, that are using just encapsulation of 1 or 2 or 3 values. So if you are using the JDK 16 or more, you have a warning if you start to use equals equals on them, because
Synchronize as well.
or synchronize, yes. Synchronize is perhaps because currently it works, but in the future, either the semantic will change. We have seen that equals equals change, or if you are using synchronize on an integer, soon it will not work anymore. I think I can repeat. If you are synchronizing on an integer, I know that some of you have done this.
Yeah, but
Soon it will not work anymore.
yeah, so read the warnings.
Yes.
Don't ignore them.
Yeah, but it's JDK 16, so you have to use a fairly recent JDK to see the warning.
Okay, let's talk about memory. Memory layout of arrays. So for instance, I have this array of temperature. It's an identity object, so the one that we are using for now. And that's the structure of the memory. If we have such an array, we have all the elements. They are references to a temperature instance. And we have, of course, a header and some padding bytes at the end because we need it for alignment for the CPU to be happy. And each of them, each element is a reference to somewhere on the heap where we have, again, an object. So we have a header, we have the value, and some padding bytes. So as you can see, we have two main issues. The first one is the cost of indirection. For instance, if you are iterating over your array, you will be chasing the pointers. They might be scattered in memory, and that's really inefficient. And the second cost is the memory overhead. As you can see, we just want to store 4 floats, and we have so many bytes that are needed in memory. So much more data for the headers and padding rather than the data that really matters for us.
Yeah, so currently the header is 96 bits of memory.
Yeah, so that's not very efficient. What about value types? So we can do some flattening, some optimization to make it more dense because we don't have identity anymore. So for an array of temperature, we could store it in such a format. So we store the float value, but as you can see, we need an extra bit because we need to know whether the value is null or not. And that's kind of annoying, but still, that's much better, much denser. We don't have to chase pointers. We use less bytes, so that's kind of good. But it's still quite costly because we would require on 64-bit CPU 8 bytes, 4 for the floats, 1 for the null flag, and 3 that are left unused, unfortunately.
So yeah, on heap, if you want to store a boolean, you need 1 byte, which means that for only 1 bit of memory, here you need to double the size of the space that will be used, which is kind of annoying.
Yeah.
It's less space than using pointer, but it's still more space than what you can think if you forget that all things are nullable in Java.
For simple types that we have in the JDK, as Remi said, Boolean, we need this extra byte. For a character, we need 2 bytes, so we will have 1 unused byte. And for an array of integers, it's kind of same as float, 32 bits. And again, we will have 3 bytes that remain unused.
So yeah, the reason we need those unused thing is that we want to be able to load the value in one read. Because if you need 2 reads to read the value, you maybe read the value null and then the value after, which means that another thread can write something which is null but not yet null for the first thread. So we don't want this kind of thing, which means that from the CPU point of view, if you want to read a value instance, you have only one possible read. That's why we have this big empty space, unused space right in the middle. Because on the CPU, if you want to read something on the heap, it's either 8 bits or 16 bits, 32 bits or 64 bits. You cannot read 24 bits.
So what about fields? We talked about arrays. For fields, we can also do some optimizations. So let's say I have a really simple record. It's not even a value record, it's a record, but it's encapsulating 2 booleans that now are value records and a double.
So it's boolean with a big B.
Big B, yeah.
It has 3 possible values.
And we would have something like this, so 2 bytes for the boolean, we already see that. But for the double, a double is 64 bits plus the null bit, 65. So 65 bits on my CPU, now it's not possible. So the JVM will still use a pointer. So we have kind of a partial optimization done by the JVM. When we cannot optimize, we don't optimize. And we can. Let's do it.
So one thing you can do to improve this is to ask EMD and Intel people to have not 64 bits read, but 128 atomic read. It would help a lot.
So there is a JVM option that prints the inline layout.
So this is a diagnostic option, but you can ask the VM what is the layout of an object in memory. Exactly what is the layout of a class that contains at least one value classes inside.
We're a bit late. I don't know. Maybe you can.
No. Show it.
Okay, let's do it.
Okay.
So here is the record I just shown you in the slide, and we can run the app with these diagnostic options. And I don't have it, so I have to type it. Okay. So I will modify the edit, the VM option. Okay, let's go. And voila, I have a lot of debugging information.
So by default, because Boolean, integer, and so on are now value classes, even just running the VM, you are using already the optimization of the value classes.
And as you can see, 2 booleans are flattened, only 2 bytes, but the double is stored
as a regular object.
Yeah.
So still a pointer.
And I think that's time.
Yeah. So this.
There was one.
This is the end of our presentation.
There is the app is on GitHub, on Remi's GitHub, so you can have a look. You can play with it.
In 2 weeks, we should have a new preview that you can just download, because currently you have to build the JDK from the sources if you want to use it, which is not that ideal.
Yeah, on Windows it was quite a pain, but
it's simpler on Linux. Okay, thank you.
Thank you very much. And if you have some questions, you can come ask us.